Look what showed up today. This is the variable speed, non-ducted Furrion chill cube air conditioner. And this is the ducted version of that same model. And from the outside, these two look identical, but under the hood, they're actually quite different. And in today's video, we're gonna be taking a deep dive into these air conditioners, learning all about them, and then actually running them and taking real world test data to figure out how they perform. Then we're actually gonna take one of these, install it on our RV, and get real world comfort data to see how much we actually like it. Future Tom here with an installed air conditioner. You're gonna wanna watch this video all the way through. I've found multiple things that only this air conditioner does that are really cool, and you're gonna wanna see the data that we got off it because it's pretty interesting. Now, this isn't just another air conditioner. The variable speed in the name is what makes it so special. Variable speed is equivalent to basically what we would call an inverted mini split, and there's a lot of reasons that you want that in your air conditioner, and I hope that most of the industry starts going this direction. Furrion was the first to release this to the RV market, and I applaud them for stepping outside the norm and creating something different. I've been excited to test one of these since the first time I saw it, and now we're gonna get some real world data here. Now, I am gonna mark this video as sponsored because Furrion did send me these to test out, but I'm under no obligation to say anything specific about them, so you're gonna be getting my real world data, real world opinions about these units. Now, I can intro all day long, but it is 90 plus degrees in this garage, and I am excited to wind one of these up. But before we do that, let's take a look under the hood and see what these are all about. First thing you're probably gonna notice about this unit is that it is not low profile. This unit, in fact, stands about 14 inches tall. That is gonna be a drawback to a lot of people, primarily for the look, I think, but it actually has the smallest footprint on the roof itself of any air conditioner that I've seen before. It comes in at about 27 by maybe 28. So smaller roof footprint, and it also allows for much taller evaporator and condenser units in there, which is going to be able to enhance performance of the unit. Low profile units are great for look, but they are a challenge from an engineering perspective. So maybe we're gonna see performance in efficiency. I don't know. Let's get inside it though. First, for the non-ducted version. You ready for this? Now, if you don't know what you're looking at, this probably doesn't mean anything yet, but from an experienced RV AC guy, this is immediately different than anything else I've seen. Okay, let me break it down for you. Back here is the condenser unit, which is how the heat is actually ejected from the unit. This is our compressor, and then up here is the air side. And in almost all RV air conditioners, the air comes up, goes through the evaporator, which cools the air, and back down into the coach. And in the past, almost all units had one single motor that sat in here and drove the fan to actually do the outside air and the inside air together at the same time. But this unit is different in that the internal fan motor is here, and the fan is very different. The fan in this unit is like a mini split. It is a long, large fan that goes across the entire airbox. And that is a game changer because in a variable speed unit like this, we can vary the speed of this fan, we can vary the speed of that motor there, which drives the external fan in here. And this is very similar to a mini split. And between those two units and being able to vary the compressor, we can optimize the cooling to its perfect situation. And that is really cool. Wires are really well run. It feels very high quality build, pretty thick foam in here. While this is really cool, I kind of want to dig a little bit deeper and see what's inside this airbox. So let's go ahead and take it apart a little further. All right, there was a lot holding that together. Hopefully I can remember how it went together, but there we go. All right, here we go. Look at the size of this fan. This is going to be a game changer for interior airflow. This is not what any other RV air conditioner fan I've ever seen before looks like. And before we even run it, I just know that this is going to create a lot of airflow at a much quieter sound than the larger circumference or diameter fans that spin at a higher speed. It's just the nature of the design. You can see here where our height is coming in. This is a very tall interior evaporator unit. It's measuring at about 10 inches tall by 13, 14 inches wide, something like that. An interesting thing we're going to see here is that this is actually a capillary tube unit. There is no TVX here, so it is just a straight run. Another temperature sensor here. This thing has an awful lot of sensors on it, and it's just so cool to see these variable speed units. Interestingly, these appear to be 300 volt brushless DC motors, which is standard in these units, but the compressor looks like it runs around 180 volts. These high voltages help with our efficiency of the unit overall. This is a three-phase, actually I think all of them are three-phase brushless DC units. The brushless are also cool because they can adapt to their speed. They actually will know what their RPM is, and they can up and down their speed depending on load. If there is like airflow blocking a situation, they can change their speed. The other interesting thing about this unit is that the air goes up, forward, and down. And that is backwards of every single RV air conditioner that I have seen. Almost always the air goes this way, over and down. And that one is that way because this is not how the ducts work in RVs. But the design of this unit doesn't require ducts, so it blows the air this way and it goes up and over this curve, which is designed to work with this fan. I'm just blown away by this design. I think it is so incredibly cool. This unit here actually appears to be just straight up from a mini split as well. You can see that it has additional features, additional compressors, additional water pumps, things on it that aren't used in here because they basically took a mini split and crushed it into an RV air conditioner. And that is really cool. So while I've got this one opened up, let's take a look inside the ducted unit so you can see the differences. Okay, before we open it up all the way, you can already see this is a different unit significantly, and it only has one big motor here in the middle, which means that it has the traditional RV air fan for the inside unit that is connected to the outside unit. Now, there's going to be pros and cons to that, and we're going to take a look inside. Otherwise, it's pretty much the same. We got the same electronics, the same compressor. I mean, a little bit different, actually. Compressor's slightly different. We got some different foam, different things to keep it from rattling, probably just because it has a slightly different connection, and the way the pipes run is a little bit different. But let me open up the rest of this so we can take a look at the differences between the two. All right, and now you can see the major difference. This is much closer to a traditional RV AC unit, and this is actually a pretty wide fan as RV AC units go. But compare it to that. I mean, this is impressive for sure. Now, there is a reason that you might want to do this over that anyway. This is definitely going to be spinning at a much higher speed to achieve the airflow that it needs. And because of its circumference and the higher speed, I'm guessing this unit is going to be able to put out more what we call static pressure in the HVAC world. This unit is going to produce a lot of airflow, but it's probably not going to produce a lot of static pressure. I could be wrong about this, but I actually have a tool called a manometer that we can test this with. This design is inherently going to be louder as well, though. So that is the big difference between these two. Once again, the airflow here goes up, through, down. In here, it's actually going up the back, through, and down. Otherwise, it's pretty much the same. I have really high hopes for this to be extremely quiet inside. This unit is probably going to sound closer to a normal unit, but being ducted, it should be completely sealed underneath, and that helps with the noise a little bit. Now, while we have these apart, I want to showcase one more thing that's hard to see on this one, but over here you can see really well. I've already run this unit once, and I was able to see the condensate. It comes off these fins, and most of the time it comes out to here and just drains out onto the roof and dribbles away on our RV and drips down the side of the RV and stains it all up. But they did something really unique here. The condensate channel comes through here. It's actually not got any holes in it, and it goes all the way back underneath the condenser unit in the back. And what happens is it actually fills water up in here, and the fan, if you look in there, you'll actually notice this fan. See that ring? It's actually got a ring around the outside of the fan. And you see what that ring is doing? It actually spins in the water that has come off of the roof, and you can see the water is actually up against the fins down there. And what it does is it soaks the outdoor condenser unit in water, and that is going to help cool it. It's brilliant. Using the water to help cool the exterior unit is going to make the whole system more efficient. Now, the drawback that you're going to have to this is that it is connected to the outside fan. So if you're just running the interior fan, you can't run it any slower than the outside fan. So the unit can't vary its speed as much as the other unit that has the multiple fans. But I'm guessing they had to build it this way to achieve the traditional design with the units they had, because there is a non-variable speed chill cube unit already, and it's probably very similar to this, except without this big brushless motor here. Now let me see if I can put them all back together so we can start running them. All right, got them put back together and didn't have any leftover screws or parts, so I think we're good to move on to testing them. What we're gonna do first is we're gonna just run the fans on the interior fans on both of them so you can actually hear what the sound is like compared to one another. We're also going to be taking power information, and then I'm also going to be taking airflow from the ducts with this Testo anemometer. It's a hot wire anemometer, extremely accurate and sensitive for figuring out airflow in ducts. Then we're going to use this tool, which is called a manometer, to actually figure out what kind of static pressure these fans can build. Now keep in mind that the ducted unit's exterior fan runs when the interior fan runs, and we don't have a roof to close off that sound. So it's going to sound louder in this garage than when it is on the RV. But it's still going to give us an idea of the tone and its sound inside. We should also be able to tell how many watts these interior fans use. Let's go ahead and hook this up and start listening to these fans. One more thing before we fire up this fan, I'm going to be using the OSHA calibrated app for figuring out the actual sound. So I'm going to show this for each fan speed. Let's go ahead and be quiet and figure out what our base level is. First impressions, this is amazing. This is the best sounding air conditioner I have ever heard. Now, the compressor and the exterior fan are not running, but this is basically what it would sound like coming down inside the RV. And even at low speeds, this thing might be the king of airflow. I mean, this is amazing airflow on low for so little noise. I'm in love with this already. That is so cool. Now we're going to take the manometer which I just poked through a cereal box, and we're gonna figure out what kind of static pressure this unit can supply. You can simply just see the hole there. So we're just gonna put this over it and then slowly block the airflow. 0.35. It's actually pretty good. 0.35. 0.35. All right, once again, I'm gonna block the airflow and check out the static. 0.7. 0.65. So I think my theory about the static pressure on the ducted unit is right, that smaller fan turning a lot faster can definitely move airflow at much higher static pressures, which is better for ducting. It's amazing that even though that fan is so big, it just doesn't produce the same static pressure. So hence the ideal fan for a ducted unit is this one. So now it's time to take actual data from this unit and see how it actually performs. What I'm going to be doing here is wiring this up with a bunch of sensors. We're going to be taking input, output temperatures, and the airflow. Then from that, I'm going to be able to actually calculate the BTUs per hour that it is able to remove from the air. I'm also taking the voltage and current input, and from that, I'm going to be able to figure out its wattage, how much power it's consuming, its power factor, and its voltamps, how much energy this unit consumes. With all that data, then I'm going to be able to actually put it all together and calculate its energy efficiency ratio, or its EER. Now I've got it all wired up with these sensors, and I've written a custom piece of software that takes all of that data, aggregates it together, and then actually gives me those live readings and also graphs it. I'm also just logging all of this data so that I can analyze it in more detail later. Now I have been running this with the shroud off, and what's unique about this unit is the shroud is not required to actually run it because it has an air distribution box here in the back. Most RV units require the shroud to be on because they're part of the airflow, but I think it's kind of cool that this one doesn't require it because those shrouds frequently get warped and damaged a little bit. If you have something crack it, it's not going to matter with this unit. You're not going to lose airflow, which is pretty neat. I am going to put the shroud on though, just to get a real world as close to actual data as we can before we run it. Now, before I put it back together, I want to talk about one more thing about this unit I find interesting is that because it's drawing the air in and has its own air distribution shroud inside it, I think this unit's going to be a little harder to clean the exterior condenser coils. And that's because all of the air is being drawn in and it's going to push any debris up against that condenser on the inside, not the outside. So it's going to be harder to actually get that debris off. From as we talked about earlier, because that stays wet on the outside too, I think there's a higher probability of mildew forming on those coils. So I think it's going to be really important that you maybe take a hose once a year or so and hose that outside coil down from the outside to push any gunk that's built up inside it out. RV air conditioner maintenance is something people frequently neglect to do, but it's actually really important. I say at least once a year, clean your exterior condenser coils, maybe even more often if you're in an area that has a lot of stuff in the air. Like right now, the cottonwoods are exploding around us, and we had serious buildup on all of our air conditioners' fins. So keep that in mind. These will lose efficiency if their airflow gets blocked. So I'm going to run these tests, and then we're going to get this on the RV, and then I'll be back. One more thing before I put the shroud on this, I want to show you what the startup of this actually sounds like. I'm going to go ahead and turn on the cool in low mode here, and you're going to be able to see this fan start up and then turn on the compressor, and you're gonna be able to hear them ramp up super slow. This unit has zero startup surge. It will start from zero and ramp up extremely soft. So believe it or not, the interior fan is already on. It's so quiet. All right, here we go. We're gonna put it into cool mode on low, and here's what it sounds like. Exterior unit. And that's the sound of the compressor firing up. and it's running really slow here, but this can vary, and this will increase speed too. How cool is that? I can already feel cold air coming out. It's just awesome. It's just so awesome. See how the table's wet here? It's actually spraying out the condensate. So you see it here? You know how we could see it picking up the water earlier? Well, it's soaking the fins. And right when it started to soak the fins, look what the data showed. Right here. This is when the fins started to get wet and the energy started to drop and the BTUs went up and the efficiency went up. How cool is that? This unit is using the condensate that would normally just drain off the roof of the RV to make itself more efficient and get more cooling out of it. This is just so incredibly smart. From my understanding of compressors, it's not actually going to be able to exceed the energy that the compressor is rated for, but it's definitely going to lower the head pressure by cooling those exterior fins and increase the efficiency. Opened it up after the run. Look at this. It's all wet in here. Everything's wet. That is interesting. Compressor got wet. This got wet. You can see all the water in there. I mean, it's great for efficiency and performance. Very interesting to see. Hopefully everything's waterproof. So here's where our existing air conditioner is that we're going to be replacing. You can see I've got duct silencing stuff in here. I'm going to be cutting out these ducts because we're going to be turning this into a non-ducted unit. Watch my previous video if you want to see why, how bad ducts are in an RV. So I'll test this existing unit for sound for you, and then we will we'll go ahead and start cutting this out. If you have an air conditioner that actually runs the furnace as well, like this Psychometric unit does, these two wires are what actually command the furnace to come on. And I have already disabled this system by using a thermostat directly to the furnace so that it doesn't require the air conditioner to turn on the furnace. That's a relatively simple thing to do. I'll have more information on my blog post about how I did that. I'm a little unique in that I run Home Assistant in this RV though, so I did mine all digitally. All right, I'm gonna start taking apart this old one and we'll go from there. Boy, that's gross, isn't it?
Yeah, it's like a pond environment under here.
The problem with these rooftop air conditioners, stuff always gets trapped under them. It gets gross.
Yeah.
They really glued this one down. So this one, the condensate actually ran in these lines through the roof. And I even, when I retrofitted that one, I put it back. But with this new one, hopefully we're gonna have less condensate off the roof because it's gonna use it for cooling. But we're gonna cut out all this ducting
and clean this up.
and clean it up so that the new one can sit and go non-ducted. Up and down. Did it beep?
It beeped, and it's moving.
What do you think?
I like this volume a lot. What an improvement.
That's in low mode, but even in the high modes, it's just not near. I would say in the high mode, it's still like half the volume of the old one. It's just a better tone.
Low mode was not an option on the old one.
No.
It was either off and doing nothing, or a freight train in the bedroom.
Sleep in this room. We never ran it while we were sleeping because it was so bad.
Yeah.
I mean.
Oh, I'm so excited. Best summer of sleep I think we'll ever have.
What do you think? This thing's been installed for about a week now, and it has been pretty impressive. It's been really hot. It's 88 degrees outside right now, and it's holding a lovely 75 degrees in this room. It is running right now. It's running on low, and I don't think I ever could have filmed a video this close to a running air conditioner before. I do have laundry going in the other room as well, so you might hear some of that, but in general, the sound is just incredible. I know a lot of you have wondered how loud this thing is. I'll give you some actual sound comparisons to the old unit that we took out, and in general, I'm impressed. We've been able to sleep in this room with the thing running directly over our heads set on low, and it just hasn't been disruptive. It also has zero startup clunks or anything weird about it that so many of our previous air conditioners have had. Now, before we get into more of the actual usability of this unit, let's talk about the data that we acquired from our runs in the garage. Now, I will make all of this data available over in the blog post that I'll post alongside this video, but let's quickly go through it. The first thing that we did with these air conditioners is we ran them all the way up to their maximum to see how much BTU capacity they actually put out. I did also have to create a special duct underneath the ducted unit to get correct airflow, but I feel like my results are pretty accurate. Here on the non-ducted unit, running it up to its maximum, it produced a maximum of around 9,000 BTUs. Best case, it topped out around 9,500, but it typically held about 9,000 BTUs maxed out. Now that was after it started doing its condensate magic trick, where the condensate coming from the interior unit flowed around to the back fan and sprayed on the rear condenser coils to help cool them down. That also brought the power down just a little bit and the energy efficiency up. The power consumption was averaged around 1600 volt amps full out with an EER of around 6.5. Now the ducted unit made about 10,500, topping out briefly at 11,000 BTUs maximum. Its power consumption was very similar at around 1,500 volt amps once it stabilized, and that equated to an EER of around 7.7. Yes, the ducted unit was slightly more efficient. Why is that? Well, it has to do with the compressor. The ducted unit has a different compressor. It is slightly larger, and the rating of the compressor itself, its BTU capacity, is actually 10,500, whereas the non-ducted unit's compressor was rated at 9,500. And we basically matched those numbers exactly in our tests. And that also means that this unit does a fantastic job utilizing that compressor to its maximum. Frequently in HVAC systems, we see a actual lower output from the compressor's rating because there's inefficiencies in the system, but this thing basically is maximizing the use out of those compressors, and that is pretty awesome. Now you might be thinking, but aren't these things rated at 18K? Well, supposedly. It says 18K all over the package, but it only makes around 9 to 10,000. Yes, and I don't have an answer for that other than the RV industry has for a very long time overstated the BTU capacity of air conditioners. I also found the compressor being used in this unit in a mini split that was rated at 18K, but it's just not right. And I'm guessing that's where those numbers came from, but it's just not even possible for it to get to 18K because its compressor is just not large enough. Many mini split manufacturers slightly overstate their ratings as well, but usually from what I've seen, they still have compressors that are much closer to the ratings of the unit than this, which is pretty low. If you want a comparison, I did take the old unit that was on the roof of this RV and took it to the garage and ran the exact same test parameters on it, and it maxed out around 9,000 BTUs, and it's rated at 15,000 BTUs. I've tested another of the exact same unit when we removed a previous one, and it basically made the exact same ratings that I'm seeing here, 9,000 BTUs, but its energy efficiency was about 5, so significantly lower. Now this is running maximum full out, and that's all the old unit could do. When it hit its temperature set limits, it would just shut off really hard and it would actually clunk and make a lot of noise. Its startup, its shutdown were just awful. But these new units have an extremely variable, because that's what they are, energy consumption, BTU, and energy efficiency. And when they ramp down is where the magic really happens. First of all, taking a look at the non-ducted unit, when it's running at its absolute lowest, it's putting out around 5,000 BTUs, and it's only using about 520 volt amps of power. That equates to an EER of around 13 on average, which is insanely efficient. And 5,000 BTUs is still respectable. In fact, that's probably about what it's putting out right now, and it's keeping the back of this RV nice and cool on a 88-degree day. The ducted unit did slightly better, putting out almost 6,000 BTUs at its lowest power consumption, running in about 520 volt amps, very similar on the power, but giving it an EER of around 15, absolutely mind-blowingly efficient. Now, it's good to see those slightly higher efficiencies on the ducted unit, because you're actually going to lose pretty much all that efficiency pushing that air through the ducts. You're going to lose airflow, and on a hot day, you're going to lose heat directly through the roof of the RV. Watch my previous video on ducts if you want to learn more about that. Stepping it up to about medium run, the units both put out around 8,000 BTUs, and their EERs stepped up between 9 and 11. They also stepped up a little bit higher to the 75% run, putting out 8,500 or so, with an EER dropping down to about 7 or 8. In general, really solid performance at the lower end. I would say, in fact, that this is probably a low-powered king. I don't think I've ever seen an RV air conditioner with such good efficiency per the energy it's putting out. Really, really great for if you're running on batteries with solar or a generator. Now, you may have noticed that I was talking volt amps, not watts. Volt amps includes the reactive power component, and that's actually something that this unit doesn't do very well, is it does not have a great power factor. Now, in the past, I've talked about power factor and assumed that most inverted units would have a good power factor, but this unit does not, coming in between 0.72 and 0.82, depending on the load it's running at. And that is just not very good. It means that there's upwards of a couple hundred watts of reactive power in the system that an inverter or a generator is going to feel, but wouldn't necessarily be measured on the shore power side. Quick note, while editing this video, I realized that I spoke about power factor like everybody understands what it is, but I'm an electrical engineer and this is something I deal with all the time, but it is kind of a complex topic that I just can't explain in this video. So it is important. We have been using this air conditioner off-grid a lot. I'm currently off-grid right now while I edit this, and the air conditioner is doing a great job dehumidifying this coach. I can confirm that my inverter is seeing that full volt amps that we had talked about earlier, so that reactive power is really there. But this unit can back down so low that it is my preferred air conditioner to be running while we're off-grid right now, because I can control it so incredibly well. And one other thing I didn't notice when we were running it in the garage is I didn't let it get to its set point, and it actually can back down even lower than we saw when we ran it. It can run down to about 200 watts of consumed power. We were seeing about 230 watts with that reactive power included, which is so low and fantastic for an overnight run. For anyone interested, this unit has been consuming about 2 kilowatt hours of our battery for an 8-hour run while sleeping with moderate temperatures. Now, I have seen air conditioners do a bit better than this, but they're DC-based air conditioners like we use on our truck camper. However, those have the drawback of being less efficient when they're on-grid. So if you're primarily off-grid, I definitely recommend leaning towards a DC air conditioner. But for general use case where you're plugged in, this is a really great unit for kind of all scenarios. If you are setting up an off-grid primary situation or a microgrid like we have set up here, I do recommend that you learn about power factor, because it is an important thing when you are managing your own power system. Now let's talk about the actual functionality of this unit. Let's first talk about the good. This unit has insane airflow. This mini split style air distribution system that can swing, if I put it on swing here, it'll swing back and forth, does a great job moving air through the coach, and it moves a lot of air. This non-ducted unit actually had higher cubic feet per minute air movement than the ducted unit, but again, without the static pressure, so it really can't be used in a ducted system. Just having that really great air distribution makes it way more comfortable in the coach. It just really doesn't have hot pockets very much because it's moving so much air, and it just works. The swing even pushes the air backwards a little bit. So when we have this rear door open, again, I'm doing laundry back there, so keeping it closed for quietness, it actually can push some of the air backwards, and the room behind here actually stays pretty cool if the door is left open. If we're trying to cool the front of the coach, we can also just point this thing towards the front and turn off the swing, and it does a great job just rocketing that air towards the front of the RV. Overall, amazing with this air distribution. Another thing we love about this unit is the ability to turn on and off the LED screen that reads the temperature or the mode via this little button on the remote that says LED. And when you do that, it turns off the beeps. Right now, with it off, I can change the temperature and it doesn't beep. But if I turn it on, you'll hear it beep every time you make a change. We've been saying for years that we want less lights in the RV, or the ability to turn the lights off on appliances for, say, sleeping and making it dark, and also to make the dang things shut up. We absolutely hate having it beep when, say, you're trying to sleep or a partner's trying to sleep and you just want to change the temperature of your unit. You don't want it beeping all the time, and they finally did that. Way to go, Furrion. Now overall, the fan settings work really well in this unit. There's a low, medium, high, and turbo on the non-ducted unit here. The ducted unit is missing that turbo. But if you set it to any of these modes, it basically holds that fan speed and does not really change the interior fan speed, and is really great for sleeping. Just setting it in low, it will cycle its compressor on and off as necessary, and that cycling is so smooth and quiet. There's no clunking, there's really no noise. It keeps all the compressor and the fans running really low, and it's just a really nice unit based on sound and comfort. That being said, in auto mode, it does swing the fan pretty significantly, a lot higher than I would like when we're sleeping, so generally we just keep it in low. However, if you have it in auto mode, it will actually turn the fan even lower than low mode, but keep it on. And I think that's a fantastic thing, because a lot of times you want to continue keeping airflow across those coils, especially if the compressor's been running, because they're wet and you ideally want to dry those off. Keeping coils wet in an air conditioner is just a great way to get kind of a smell, a little bit of mustiness. Drying them off by continuing to run air through them is a great option. So it's nice that the fan doesn't shut off. Auto mode, it's lovely that it gets even lower, but in auto mode, it ramps up to high, and when you're sleeping and it ramps up real high pretty quickly, that's a little bit of a drawback. I would love to see a mode in auto where you could limit the high end of the fan. Now, generally this unit doesn't run maxed out either. It will run really high when it's first turning on and it's hot in the space, but it will back down relatively quickly into those more efficient zones. So overall, I don't think it's going to be running at that 6.5 to 7 EER very often. I think it's going to be closer to 8 to 10 EER for kind of normal operation. In low mode like it is now, closer to 13 to 15. Amazingly efficient. And that's the beauty of these variable units, is that they maintain temperature so incredibly well. They find the need to run instead of just cycling on and off. The older units would just cycle on and off more frequently or stay on longer if they're trying to maintain that temperature. And again, that's just annoying. This unit doesn't do that. It just ramps down, finds where it needs to be, and that is also where it's most efficient, which is awesome. Another great thing about this unit that I didn't know it even did was the consumption of the condensate via the exterior fan and condenser unit. I have not seen a drip come off of the roof of this RV since we installed this unit. That was something I was a bit bummed about when I installed this unit, is that this RV actually has hoses in the roof to direct the condensate through the ceiling instead of dripping off the roof, and I absolutely love that. But I couldn't reinstall that system with this air conditioner. But it didn't matter, because this thing has barely dripped any water onto the roof at all. It basically evaporates it, consumes it in the fan, or flings it in such minor droplets around that you don't even notice actual water coming off the roof. Now, I'm sure in certain circumstances, extreme humidity, you're still going to get some, and I have seen a little bit drip out of the unit, but not even enough to make it to the gutter of the roof, which overall is a huge pro for this air conditioner. I also love the 50 and 75% maximum buttons that allow you to force it not to run at its maximum. If you're really looking for maximum efficiency, you could set it at 50 or 75% and it would stay within that super efficient zone all the time, never ramping up to its maximum. And this is just going to be a game changer for somebody who wants to run this on a small generator off grid. And it actually works. It does exactly what it says it's supposed to do. And honestly, I didn't even see that advertised in this unit. So again, huge thumbs up for thinking that one through. Now let's talk a little bit about what I don't like about this unit. First of all, it doesn't have an app or any way to wirelessly control the unit other than this controller. And this controller is an IR controller, meaning it has to be pointed at the unit for it to get the signal. The functionality is great. It allows you to control everything from here. It even has something called a follow me feature and a thermostat in this that will basically use this as the temperature sensor, which is a great idea in theory, is that it'll basically run up to the max to try to cool this to the temperature that you set it at. But this has to be line of sight and it has to be able to talk to it. And I've found that frequently it just doesn't reach it very well, so it's not getting the signal. But I would also really love to see an app controlled by Wi-Fi and or some other comms coming off of this. RVC would be an awesome option. Now the ducted unit does have this. It has a secondary plug on the back of the ADB, and you can get an additional adapter that can connect directly to their Furrion thermostat that you could install anywhere, and it does have RVC capable communications. In the future, I might try installing that and try tying it into my existing smart system in the RV. As I mentioned before, I use Home Assistant to control my furnace. I would love to be able to connect my air conditioners through that so I can have full featured thermostats for all the zones of the RV. Now this unit is also not a heat pump unit, meaning it is strictly an air conditioner. It does have an option to put heat strips in it, which are resistive heaters. And that's a great option for really cold environments because it doesn't have any low limit, but it's basically like running a space heater in the RV, and the efficiency is basically one. You get the exact amount of heat as the energy you're putting into it. And that's the beauty of a heat pump, is that you actually get more heat than the energy you're putting in because you're moving heat from the outside to the inside instead of just creating it. So there's kind of pros and cons there, but in general, I love having heat pumps in the RV, and it would be nice to see that in this system, but it's really just a great air conditioner. Now, the last drawback I've got on this unit is its profile. I think a lot of people prefer the low profile, primarily for the look. This is a very tall unit, like we talked about before, but I was surprised at how small its footprint was on the roof. It was similar in width to the air conditioner I took off, but it was so much shorter than the existing unit, which would be great if you want to put solar or other things on the roof. It just minimizes the footprint and goes up instead. That also allows for the awesome air movement inside the unit, however. So I guess there's pros and cons to its tall profile. So in conclusion, this is absolutely a solid performing AC that has taken RV air conditioning a huge step in the right direction, and I applaud Furrion for making such a unique unit. It's not the perfect unit for every situation, but it's definitely in my top tier recommendations for general RV air conditioning needs. Recapping on the things I've only seen in this air conditioner, those generator limits and how well they work, the condensate consumption on the roof and no dripping, this amazing air distribution unit and the ability to swing that air around, its amazing low power performance and efficiency, and that fully variable internal fan really make this unit stand out from the competition. My biggest frustration with this unit is definitely that it didn't meet its BTU ratings, but I think there might be opportunity there as well. I think the coils in this unit could handle a bigger compressor, and it would be cool to see them offer a 9, 12, and 18K unit like most mini split manufacturers do. For most RV needs, this power is probably just about right. But for bigger rigs like ours, or ones that are painted black, having a few more BTUs would be pretty nice, even if it costs a little bit more. I'm sure you can tell I've been pretty geeked out about this unit, but if you want to dive into some more of the details, if you want to look at my data and see my calculations, again, I will put them all on the blog post linked alongside this video, so you can dive into all the data yourself. As always, thank you so much for joining us here on Morton's on the Move. I hope you've enjoyed diving into this air conditioner as much as I have. Stay cool, and we'll see y'all down the road.